Question 12a was as follows. The mass M of a bag of maize is 62 kg to the nearest kilogram. Complete the statement in the answer space. Okay, so here, for you to complete the statement below correctly, what you need to do is first you need to take note of the quantity given. So we are told that it was 62 kg. So this is the same quantity we're going to get and write it here. Okay, now to use this number to find to complete the statement below, what we're going to do is what we're trying to do is we're trying to find the low bound and the higher bound. Okay, the lower limit and the higher limit. So what we should understand here is this. We are given this 62 kg. So what we'll do is we're going to get rid of the unit, and then we're going to just focus on 62. Okay, when you go to the statement, you see that it's written that to the nearest kilogram. So here the smallest unit is 1 kg. So we're going to write 1 here. Okay, the smallest unit is 1. Okay, then if this is the smallest unit, then which means we're going to multiply this 1 by half, which is going to be multiplied by 1 over 2, and it's going to give us this, the product, which is 0.5. Now for us to find the lower bound or the lower limit, what we're going to do is we're going to subtract 0.5 from 62. So we're going to say 62 minus 0.5, which will give us 61.5. Now this is the lower bound or the lower limit. So we are going to write on the left side of this statement, we're going to write 61.5 kg. You should not forget the units now. Here we're bringing back the units, so we're going to write 61.5 kg. Okay, so we are saying the mass of the bag of maize is greater or equal to 61.5. Okay, then we can go to now we complete the other side. So we're going to find now here on the right side, we want to find the higher bound or the higher limit. So meaning we're going to write 62 plus 0.5. So we're going to say 62 plus 0.5. When you add that, it's going to give us 62.5. Now 62.5 is the higher bound or the higher limit. So it's the high limit. So we're going to say M is less than 62.5 kg. So meaning when the measurement is taken, that means this measurement is ranging. This is just approximately, it's rounded off. So I'm saying this measurement is greater than 1.5 and less than 2.5. So the actual measurement is between 61.5 or is between 61.5 and 62.5. Okay, now we can go ahead and go to next question. Question 12b was as follows. A woman estimates the weight of her dog to be 13.15 kg. The actual weight of the dog is 10 kg. Find the percentage error. Okay, so we asked to find the percentage error. So to find percentage error, what we do is, or the formula we use is percentage error is equal to relative error times 100%. Okay, so what we're going to do now here is we need to find relative error. So to find relative error, we're going to use the formula, which is relative error is equal to absolute error over true value. Okay, now here, as you can see, we don't know, we are not given the absolute error. Okay, true value is given, which is 10 kg. So what we're going to do now here is we are going to find the absolute error. So to find absolute error, we use the formula, which is absolute error is equal to estimate value minus true value. So what we're going to do now here is we need to find the absolute error. So we're going to, what is the estimate value? The estimate value, the woman estimated that the weight of the dog is 13.15 kg. Then in the actual sense, the true weight of this dog is 10 kg. So that is the true value, which is 10 kg. Okay, then we need to find the difference of the absolute error, the estimate error minus true value, which is going to give us 3.15 kg. Okay, now we have found the absolute error. Now we can come up with the relative error. So that means we're going to come here on the middle where there is a purple, where I was working with a purple color. So the absolute error is 3.15 kg, which will be over true value, and the true value is 10 kg. Okay, so now this expression I've written, this expression I've come up with is the relative error. This is I've come up with now relative error. So that is relative error. So now we're going to use this relative error to find the percentage error. So what we're going to do now here is I'm going to replace relative error by the expression I just circled there. So what I'm going to do now is I'm going to write 3.15 kg over 10 kg multiplied by 100%. Okay, once I've done this, then the next thing I'm going to do is I'm going to get rid of the kg signs there, so because we don't need them. So I'm going to divide what is on top and what is down. So as you can see, we've got units there which are kgs, so I'm going to do is cancel the kg down and the kg up. Then later on, now I'm going to divide 10 and 100. So I'm going to find the common factor of 10 and 100. The common factor of 10 and 100 is 10 itself. So I'm going to say 10 divided by 10 will give us 1. 100 divided by 10 will give us, in fact, 100% divided by 10 will give us 10%. Okay, then what I'm going to do now is I'm going to write what I'm remaining with. So I'm remaining with 3.15 kg, which, or 3.15. The kgs have been cancelled out, which will be multiplied by 10%. So when you multiply that, when you multiply 3.15 times 10 kg times 10% will give us 31%, 31.5%. When you multiply 3.15 by 10% will give us 31.5%. So this is the percentage errors. The percentage error is 31.5%. Let's go to the next question.